Okay, so in this video I'm going to explain how we conduct an FEA for the chassis to determine if it will fail or not under the given static and dynamic conditions. So first thing you have to make sure is that you have done all the weldments and trim extent correctly. As you can see, there are no interferences. Second thing is you have to draw the suspension mount, which you have got from assignment 1. I have just assumed a rectangular shape here. The arms are going to go here and here on each side, here and here for the double wishbone. So the next step is to have an idea where your components are going to be placed. So in this case, I'm going to assume that the passenger is going to be seated here on this seat, and the engine is going to be under the passenger seat. So what we have to do is come to the position where the component is. So in this case, it's the passenger, and we right click on a flat surface, so this surface, right click and sketch. What you need to do is I'm going to draw these small squares just like this. 1, 2, 3 and 4. So now I have drawn these 4 squares just like this, and we need to make these squares equal to each other and equal distance. These will represent the mounting point for the passenger seat, and these spaces will take the load for the passenger. So now I have drawn the 4 plates and I have added another plate in the center. So depending on the component, you can add the number of plates, but I assumed 4 or 5 plates will be enough for the passenger seat. So, and I made sure that it's fully defined. Now what we have to do is features, extrude, and I'm going to extrude these plates for like 1 millimeter. It has to be really small. Now these plates will represent the passenger seat. I have to do the same thing for the other components. So in this case, I'm going to do the engine again. So we can assume that the engine is going to be fixed using 3 mounts, one here, and one over this side. Now if I come to the top view, it's very difficult to draw here. So what we can do is use the section view from the top plane, and I can increase the height based on how I need it, just like this. So now I only have the bottom layer of the chassis. I can come to this plane, zoom in, and sketch. Now I'm going to do the same thing. I'm going to draw the plates for the engine. I'm just going to draw 3 plates for now. Okay, so I have drawn the same thing, 3 mounting plates for the engine, and it's fully defined. So we're going to do the same procedure again, and I'm going to extrude it for 1 millimeter. Make sure that the plate is not very big, so in this case I have used 30 millimeter. Don't go very big, so it will not affect the analysis. Just like that. Now I have the engine mounting plates. I'm going to assume that there's no battery in this case just to make the test easier. This is just a concept and you can add as much components as you would like. The next step is to add the mounting points for the suspension arms. So you have to get these dimensions from assignment 1. So I'm going to come to this plane, sketch, and I'm going to draw 2 plates similarly, just like that. One here and one here. The distance between the plates has to be the same distance you have from assignment 1. So let's say the upper arm opening you have is, for example, 200 millimeters. That you have to stick to that. Same thing with the lower arm. So make sure to get the right frame size. And I'm going to fully define this based on the arm size and everything. And I'm going to repeat the same procedure for the lower arm and for the other side. So I have done the mounting plates for the suspension arm, upper and lower on each side. You just have to make sure that the distance is similar to what you have from assignment 1, but the plate size can be whatever. I have chosen just 80 millimeters here. Now what we're going to do is apply the rear mounting points for the solid axle or whatever type of rear suspension you have chosen. This is fairly simple, just add two boxes just like this, and I'm going to do the same thing by defining them and making them fully defined, extruding for 1 millimeter, and then we're going to start with the analysis. Okay, so I have fully defined the sketch and I'm going to just extrude it for 1 millimeter again. And now we have everything ready. So what you need to have is all the components mounting points. So I have the passenger and the engine here. 1 for the engine, 3 for the engine, and 5 for the passenger. The rear suspension or rear solid axle mounting points, I have these two, and the front suspension arm mounting points. Next, we can start with the FEA. To start the FEA, similar to the suspension arm analysis, we go to Simulation, click on New Study. Okay. First thing you have to do is apply all the material for the chassis. Choose the material. I'm going to choose IC1020 again and hit apply. Close. Then come to the name of your component here on the tree. Right click. Treat all solid bodies as solid. And you can just minimize this. Next, we're going to come to connections. Right click, local interaction. Automatically find interactions. Make sure it's in bonded. Drag and click find local interactions. Then click OK and click yes. We don't have to do component interaction as it already does it for the weldments, so we can ignore it for now. Now come to fixtures, right click and on fixed geometry. And now we select the mounting points for the suspension arm and the rear solid axle. So select each plate, 1, 2, 3, 4, just like that. Make sure it's on fixed geometry and click OK. Next, we come to external loads. We're going to start by adding forces. So what are these forces exactly is, let's say I'm going to select this passenger plates, 1, 2, 3, 4, and 5. You come here to per item or total. I want the weight distributed around these whole plates, so I'm going to select total and add the weight of your passenger. So let's assume my passenger is 80 kg, which is going to be around, let's say, 900 newtons, and then click OK. Next, we do the same thing for the engine, and we come here, add a force, and select the plates. Make sure it's on total, and add the weight of the engine. So let's say around 400 newtons would be acceptable, and then click on OK. Next, we need to add the gravitational force. So right click on external loads again and select gravity. For the static case, we only need to add the gravity because the chassis is not in any dynamic case, so we just add the gravity and just make sure it's pointing downwards and just click on OK. Next, we mesh, so right click, create mesh. Now this is where we might face some errors, so we can try first just a regular mesh and click on OK. See, we have some errors here that we can also fix. Okay, so if you get this error, come to mesh failure diagnostic, and we have here several meshes that are not coming. So we can come to mesh control, click on use per part mesh, okay, so now we have our mesh ready. We just have to make sure that everything is meshed and nothing's missing. As you can see, nothing is missing in my case. So we can just click on run this study. This should take some time as the design is more complicated compared to the suspension arm. You have more curves, more tubes, so just be patient with it. Okay, so after the study has been done, you get the same results for the suspension arm, but as you can see here, it's a lot more emphasized. So we can just click on deformed results to just get it back to normal. And this is the stress plot. We can do the same thing, right click, chart options, show max and show minimum, and just drag it here, just like that. For the displacement as well, we can do the same thing, right click, chart options, show minimum, show max, and we also need the factor of safety plot, so define it, and now we get the factor of safety. So this is for the static case. Now to apply the dynamic cases, we come here to gravity, edit definition, and we come down to advanced, and we have several directions here. So let's say you have calculated the acceleration for the acceleration case. Let's say it in 4 meters per second square. Just click on that. So during acceleration, the weight is shifted towards the rear, so the arrow should be pointing towards the rear. Let's say you want to do it in braking case, so it's just reverse direction here. And now braking, the weight is shifted towards the front. Let's say the braking acceleration or deceleration is 3.5. Just add 3.5. In this case, I'm going to do the combined braking and cornering. So during cornering, the weight is shifted towards the outer wheel. Let's say for 3 meters per second as well, just like that. Now I have all the cases. I have the static case, the braking, and the cornering pointing towards the outer wheel. Do the same thing for each case, for braking, acceleration, cornering, and the combined case. But I'm going to do the combined case here and just click OK. Now we have to run this study again. Okay, so after running this study again, I have found the results again, and we can do the same thing with the minimum and maximum. Now these are all the results you need to analyze your design and optimize it. You need the stress, displacement, and the factor of safety.